Then I'm choking right. So 15.2, I think I'm going to jump into problem 15.2 here. Weld exploration here. Yeah, just having us do the parts, the assembly, and drawing file. I don't know. I haven't created these under PDFs. Not to say you can't, but a few of these can become a good portfolio if you want to discuss weld symbols in an interview and have this in your portfolio. I mean, some of these drawings can be good. I've gone through and added my right side views, so a lot of these, just so I can use the drawing as a what we need to do. So this one I just need to make parts to join as well. It's just a simple part. We've got a 4 like 6 inch 3/8 thick by 4 thick flat bar. That's what my part is called out as the part description. 3/8 by 4 miles thick flat bar. That's the thickness, 3/8. It's 4 inches wide. Now I need to cut these, I guess, 6 inches long to make my sheet on the welding. I'll go ahead and jump over to a new part here. Start a new sketch. XY plane, sure. We'll just make this rectangular extrusion here. So I'll say it's 6 inches long in this direction, 4 inches in this direction. We'll extrude this thing 3/8 of an inch. So let's extrude this 375, like my part. This is mild steel, so I'll just do the same thing. I'm going to change this material back. Mild steel. Sorry, it is steel. Allow just feels the appearance, save its thing. Move 4 parts. Let my parts say, let's go ahead and open a new assembly. Welding at the assembly out. Yeah. And place in, so I know it'll read over the black pad there. I'm going to put it here, place in. Essentially, just created this one here. Essentially, this assembly is just two of these, and then we weld it together. And there's two. Okay. Just ground and root one. So stay with right here. I'll use my ground and root. This one I'll buy it. And I'll strain this one how it needs to be in the building. So let me pull that up here. And so this is an outside, sorry, this is a corner. A lot of additional handouts for this kind of work. I just kind of kept it to stay. It's not that it's perfect. Sometimes handouts are a little clear, but I think this textbook really does cover it. Essentially more detail than what we're going to be able to absorb in but there's some of the stuff I do have to point out. It's good. We can read it right that joint power kind of important or really important, and it's just finding the effects once. Maybe I'm thinking, oh, I don't know, it's good. 644. In fact, that should be one of the first pages after the welding process. This is page 644. This is a corner joint. It's not an outside corner joint, but it's kind of this let me see if I can do anything. And I did say yesterday that there's kind of great both types of welds. This specific thing. So what I'll do is I'll show you. Let's jump over here. I just got to put them together. The way the assignment wants us to put them together is into one. This one's been out and rooted, so out and rooted that. So it's not rooted on. Let's go and strain this kind of face right in this face. Apply that, and then yeah. This particular joint, it'll be like this, flush like this, creating kind of a glue type joint. This is like a pipe joint. I'm just looking at it from the surface. It definitely resembles more of a cup. But on this side, it's compound, just different weld. See, see. Yeah, a little bit different weld preparation. To make an outside portal joint, let me just do, I haven't selected this one totally yet, but if I actually select this corner, maybe. Just try and do. So maybe this side, between this edge to this side. And I'm not going to apply this one yet. This is a corner joint as well, but it's an outside. And so it has very, the pieces themselves not really working with each other very structurally here. They're kind of independent pieces. I mean, where they're lining up on an edge essentially. And what it creates is kind of a fill and weld on both sides. I mean, welders like this kind of a joint type because it does on some materials or on a lot of materials, it kind of gives me a place to stack the weld. So I kind of already have like this natural little ledge to kind of sit on to place a weld. And there's not a lot of joint preparation needed. So this is maybe some welding. Maybe, you know, um, it's less preparation that the fabricator have to do to get the parts ready. These are almost ready in their natural state after you shoot the size and get the size. So what I do now on we do this. And this one we take, yeah, for certain thicknesses of material, this is going to take quite a substantial amount of preparation. Prep this well, the structural integrity. Like the material pieces are kind of working together more. They're not so independent. There are some forces where this can be better. Have the material work with its material. Yeah. So, but in order to weld it, when if materials are really thin, like in the sheet metal realm, even sometimes thinner than napalm. So we're talking pretty thin materials. Sometimes I don't have to do as much joint preparation or next to none. I can get 100% of that or what penetration. So we talk about when joints fit together. Nerd out just for a minute. I know we could just jump into this like that, but if I kind of change this a little bit of how close these made together. In some situations we need 100% weld, and we don't want the materials to touch each other, and we would call that, yeah. I mean that's something that sometimes gets figured in that I can't have any parent metal, original metal here, like actually touching itself. I need to fill the void between the two completely with an additive metal, like from an electrode or other. And then this will create maybe better joint integrity, but this can just vary on design from design. And even even as a long time fabricator myself, I never knew, sometimes the joints were designed uh, by welding engineers or by sometimes trial and error, or but there is definitely a design concept in mind here that matters. And some of the welds we pull, the weld sims that we really dive into in this week are a little bit in the weeds, and they're really specific. Um, and one of them can't. I mean, we'll do a few where we actually hold like a root opening. Right? We actually do not want the materials to touch. We're going to create a void. We're going to fill this with from both sides with weld metal, and then these two will never. And then I have kind of a different joint type. So let's just see how they want to see this. First of all, I'm going to butt these two together. So I'm just going to have them straight butted together. And then if I go over my weld tab and I look at I pull this up on my screen, the instruction that we have and how to apply this weld. So the first thing I'm going to do is just kind of mess with the type of welds here. So if I interpret this correct, what we have going on is this is telling us on the arrow side, that's the bottom side of the reference line. That's the side the arrow was pointing to. There's two sides to this joint, and the butt joint side and the fillet joint side. On the fillet joint side, this is just the fillet weld symbol. That means it's a fillet weld, and I recognize this as a fillet type joint. It is a 3/8 by ½ inch weld. And it's hard to tell, and maybe I would need this to be a little bit more clear, but um, so the first leg length is 3/8, and the second leg length is half. Um, could I reverse that? Yes. Would there be a better way to determine that? That could be questionable. I don't have the answer to that. If the first one's always like the vertical plate, I mean, that's a little bit tricky, and I'd have to look it up. Is this You could interpret it, but which way does the ½ inch and which way does the 3/8 go? What I mean by that, let's put it in that one. It's just going to be a weld here in this fillet side of this. It's a weld. It's going to be a fillet weld. The first leg length says it should be 3/8, 375. Oh, and we actually can. Oh yeah, I can. I'm not doing the weld symbol, so I can do the decimal equivalent instead for that 0.375. We go to do those in the welding symbol on our annotations. We'll use for that. And then the other one is half. I use a flat contour. There is no intermittency. It's going to be complete continuous weld from start to finish. And so I'm designating the leg length, yes. And I just need to pick my surfaces. So I'm just sending from this surface to this surface. I'm just focusing on this fillet weld that's really the same. So I said, okay. And that is the weld. It's half by, and the way it put it in, essentially for me to see, just so you know, like leg one was the one that was in this horizontal position. The vertical plate was leg two. That's half by 3/8. So I think technically, if I really analyze this, and luckily I have the weld to kind of tell, but this is 3/8, this is ½ inch. So on my particular part, I'm gonna place it like this as my front view. If I'm gonna use it this way, I think I can place it this as well. Well, let me see the way the parts are. I don't think I can do it either way. I may have to change my weld direction. Let's take a look. So it really is vertical plane coming down that is carrying 3/8 of it. So let me think about that. Vertical plate going down into the bottom plate, and that would be 3/8 well. So I do feel like I need to uh, change this. Plate going down. So yeah, I wouldn't be allowing my plates in the right one. So let's do that. Let's change that. There's going to be an edit of this thing. Here's my fillet weld that I just did. Let's just go ahead and edit this shooter. So this is, I haven't left. I could keep adding welds here because I'm in that weld tab, and I'm actually activated by doing the welds, grays out everything else. So I can focus on just welds here. But while I'm in there, I can only edit. I can keep making welds and just go back and edit them as I need to. So this one, I just need to switch. Maybe this is like one. Yeah, maybe I need 3.5. And then like, you guys probably saw that if you're watching better than I was. It's it's depositing an aluminum weld. And so I've been changing that material. the appearance of changing this material to steel, just mild steel. It kind of blends in with the other materials now. It doesn't have the weld contour. That's okay. This is actually the right materials, connect the materials. That's a factor in welding. Sure, there are certain materials that you can use others to join, but there is definitely a specific on which material I'm joining and which additive I'm using have to be compatible. Not all materials are compatible. So in this case, aluminum would not be compatible with this mild as far as a weld nugget. All right, let's see what we got. And then we got this side where I'm going to do a butt joint. I have a butt joint. And what I'm saying is on thin materials, sometimes I don't have to do a lot of joint prep and I can just weld them. And even adequately that I might be able to weld and melt the metal so much that from one side to the other actually melts and everything in between, and they do become kind of welded together from weld to weld. Even without joint prep, it's thin materials. But in thick, this is thick material. 3/8 thick, 3/8 plate is thick for sure. And um, it would require like a surface weld in this on 3/8 material. If I just didn't do any joint prep, and essentially it would look like that. It would just be like very minimal crack there if things are fit up nice and tight. I would just take off and start welding across here. It wouldn't like electricity does have some impact and it can, sink a little bit of metal. I mean, you will get a molten state of this, but not to a very deep depth, actually. And it may be unknown. It could vary from welder to welder how deeply they penetrate, depending on how fast or slow they weld or what amperage they weld at. And so just a lot of factors in a surface weld not being very strong on thick materials for sure, without some preparation. So we have a preparation tab in the weldment just next to the weld. And so it'll allow me to apply kind of the joint prep that might be required. And joint prep really usually can be done by, thick fifth axis laser cutters, could probably bevel plate on the laser table themselves. It can be done by hand and manual by like a welding technician that actually has a grinder and can actually take this down. Or they have other depending on the material type, they can cut it with an oxy fuel cutting system on a track torch, to cut a nice straight bevel on this. We could give it to a machinist in a really high controlled environment, and they could cut a bevel on this for us. And so it can be prepped in a lot of different ways, from really caveman style to high precision. And so I mean, when we're doing this weld symbol showing the way it is, it's kind of a high precision. I almost feel like it's almost a machinist that we're cutting this like that with that high precision. And so, oh yeah, so I'm just going to look over here. What is so I've got this one done. And before I move on from that filler weld, just one more thing. My rule of thumb is my leg lengths on my welds generally will match the material thickness. Um, and then and it's pretty common that I would never want to be under that. So the minimal leg length of welding probably is never under the material thickness and can be up to it and even over it. So in this case, there's a reason maybe why they needed us to do an extra this may actually have to be done in multiple passes. Even though I'm able to do it in one pass, it actually may end up being done in two passes to add another kind of lower weld to this. Like I might have the first weld and then the second weld. It's funny that weld symbols don't call out the sequencing for the welder. A weld procedure can, that for sure, and that's a different document. And our weld symbols might have a in a tail note, might call out a procedure number or something to refer to. And so, because I don't really tell the welder the sequencing and how I just tell them how much weld needs to be there and how they do that can vary and maybe another, can be determined by the welder in some shops or can be determined by the weld procedure. It specifically calls out the sequencing. So it can be very controlled or loosely controlled, where they work. And that's what I'm gonna say about that. So this wouldn't be uncommon though. I mean, it's a 1/2 inch weld. It's like a longer leg length on this bottom than the material thickness, but there might be a reason for this. I don't know what it would be, but there might be a reason for this, and it wouldn't necessarily be over welding this material. It would be kind of an outlier from my rule of thumb, but my rule of thumb is just kind of a rule of thumb. It does have there are some like goes diverging from that a little bit. I just feel like as a non-welder, a good rule of thumb is if it's that thick, I probably need at least that much weld. leg length on a fillet. Okay. So I just want to move on from that. So this to me as a welder, this is not breaking the rule. I could see that might have to put a 1/2 inch leg length on a 3/8 plate. And then this side, so I'm just going to go on and look at the other side now and analyze its weld symbol here. So this is kind of a different, it's a different shape. It's like an upside down kind of fillet weld. With the vertical on that left side too. It's just a bevel weld. I might often refer to it as a single bevel. It just means one side is beveled, but I think it's just called a bevel weld. Yeah, on your weld symbols, that whole page that has them all of the symbols library for the types of welds, kind of call this a bevel weld. And so that means joint prep has been done. And it's a 3/8 bevel, you know, 3/8. And so we look at that. I think when we pull up our weld symbol, when we switch that, we might get a little readout of how to apply that 3/8 and what it means. And then the 40 degrees is the included angle in the bevel. So that would be kind of from one straight edge over to the bevel. It's going to be at 40 degrees. And it's all going to be on that one side bevel. Yeah. And in this one, which side do you bevel? Well, that could also be something that is hard to communicate or may need to be communicated, because from the weld symbol itself, it doesn't maybe tell me which one is going to be beveled and which one is going to remain. Because technically on that joint, it might be more natural to say, well, this one's going to be beveled, which is how we're actually going to do it. But I could actually bevel this too. So even though this is kind of into this big surface, I could put a 40-degree bevel there. And so sometimes, I don't know, I can see a weldment could communicate that a little clearer. If you had a drawing that actually showed the weld, that can be communicated from drawing. And then it can make sense out of this matching drawing. Otherwise, it may need to be, and it may be obvious if the parts have been prepped. If you're the welding technician and the parts have been prepped by a machine shop or by someone else, and then they're delivered to you, and you're like, well, obviously this is doing this way. Right? So sometimes it just presents itself just based off our further documentation from here. How maybe I've detailed the parts and which one's going to be better or not, and uh, and from the engineer and perspective, that should matter, could matter, and maybe sometimes in some joints it doesn't matter. You could pick one or the other. So in this case, back to my drawing here, I just need to bevel this thing 40 degrees. So let's go to this preparation tab. Sorry, I'll probably fumble this a little bit on this question. I don't use this a lot actually, but so I go to the preparation tab. It really just kind of turns into a little bit of like our normal kind of sketch and creation, like 3D modeling tab that we're used to in a part or an assembly. So really, I think everything kind of. I'm just over here. I think I start a 2D sketch. Sorry, and I just use my my normal modeling techniques that I have. Essentially, I can just do like an extrusion cut and remove that material. And so maybe I'll just do that here. Maybe I'll come over here to this sand. I could go to either end. And I just do like an end sketch of what 40 degrees looks like here. And then just extrude that through this part. So let's try that. So if I do a sketch here, and pretty sure I get my whole project geometry sequence. So really it's this part here. That one. If you ever, let me just try this real quick. If you're ever on that where you can't select the right one, I don't know, just I turned a little bit and I could select. It's almost like it almost allowed me to like turn and grab that. I think if I'm hovering over it though, right, you can this and say select other. And then there's the other one that overlaps with it. Let's see if the side jumped out. Brings up this, and here's your two edges. You can almost select them from the bottom. So I use that all the time. If I just have overlapping, really I'm trying to get like project this and being particular to the actual part I'm feeling. And from here to here, this is where this is going to be beveled here. And so I can use these as solid and then just draw this line in here. It's going to be a line. It'll be like snapping to that point. And then I just need to snap it to here. So it's constrained there. It'll stay on there. It allows me to move it. Just dimension that out. 40 degrees. 40. And so there's 40-degree cut. How did I know to go all the way through? That is the 3/8. That is the depth. We'll get to that here when I get the weld symbol or to put the weld in. Maybe the inventor thing will walk us through. I'll kind of hover over the box and get it to read out. But 3/8 in that is the depth of the weld. So it's a 3/8 kind of deep, which is clear across that plate. I guess that's how I need to start in this corner. Because my plate is 3/8 thick. the weld it's calling out for is a 3/8 weld, which is really how thick the plate is in this case. How deeply I'm going to bevel that down into to the bottom of the weld is going to be 3/8. And so then I'm going to say finish this sketch, and I'll just extrude this as a cut. So now I just have like the joint prep tab. That's the preparation going on here. It looks like when I went into this, it turned off my other weld. I think that's normal. I think it'll come back on and leave the joint prep. But I think while I'm in here, I can actually add the weld. Now that I've removed the material for a single bevel, just beveled, I'll always say single. It's just in my head, single bevel. I'll add the weld material. So this is a groove type weld. It really is. And so yes, it's a butt joint as I'm analyzing it from this side, and it's a groove. So I'm going to put it as weld now. It's going to be a groove. I think it's the first time using this, right? Usually be the two I primarily use. Cosmetic one, I don't know. So it just says, it's just a little bit different, but it just says face set one and then face set two, kind of, surface one, surface two. You may have to toggle on full face weld. You may have to play with directional fill or radial fill a little bit. I'm trying to select my first face, which to me is just going to be like this face. Sure, that's one face of where the weld would be defined. And the second face here will be right here. And maybe I'll just, and it won't let me apply this yet until maybe I have to say face. Yeah, I think that's it. Selected from face. And now I can kind of see the weld that it's depositing in there. It has a flush finish. I could toggle on create weld symbol. Maybe we'll play with this in a little bit later. Don't worry about this yet. And then I don't think it's going to help us out. So I think I just said okay on this one. I'll get it. And maybe it's actually creating steel mile. Maybe it remembers my last selection of material. So there, it's filled it up. The interesting thing is about a groove one. And going kind of sticking with that same rule of thumb, like the thickness of my plate usually is what I need to fill up. It's all I need to fill up. So when we see welds that maybe are convex of this surface. Like when the welding technician welds this, we may not be able to super control that they don't get above flush. And so they might overfill it a little bit, and it might have a little convexity to the profile. And that's kind of what the welder would shoot for, because the minimum requirement in this type of joint is going to be, and what the weld inspector is going to expect to is that this is filled through flush, at least flush. In order for a weld to kind of support itself, it generally it'll be all the way through the thickness, and then it will be through that thickness. That's like the minimum amount of weld that I usually apply. And I don't need any more than that, but I don't want any less than that. If this was concave, if the welding technician welds across here and they leave this thing dished in a little bit, the weld inspector would say, nope, I don't have like that groove thickness of the plate filled up, and it would not be the required amount of weld. And so all the sequencing they need to dial in, like how many passes they need to weld. This isn't just done in one pass, right? With the right machinery and wire type, yes, it could be done in one pass. But sometimes with welding technicians, manually, people doing welds, they had to take multiple passes, and they had to come up with a sequence that works. They have to come up with a sequence that doesn't underfill and doesn't overfill. Because not only do I have like that, cannot be concave generally on profiles, I also can't overfill above, like usually, I mean, the rule of thumb is like 1/8 of an inch. If my weld is like 1/8 of an inch taller than the surface finish, it's excessive weld, and it will cause materials to fatigue. And so the welds can cause, even though they're overwhelmed, overwelding does cause material stress and even failure if it is the welds. So there is a minimum, there's a maximum threshold of how big the weld can be above the surface. So really the welder's just trying to target almost replacing what was taken out, at least through that thickness, and then at least flush. And sometimes we actually like plane those off to where we remove all the other weld. And and all it has is out to surface finish. And sometimes you can't even tell there's been a weld performed there if that's been done, and the surface has been finished to where it all blends in, but it's sufficiently strong. Okay, all that short. That is how I would do that well. And how I would make that work in my welding. So you can take this to the drawing, and then detail it out. I'll mostly focus on obviously I'm gonna do the full view of kind of what I've thrown up here on, thrown up on, but I think I'll just focus in my video. This is all pretty easy detailed in the process. I may need to go and have this descriptor to my property. But you want this to be creates spot for that. And then, so I'm just going to focus on the weld symbol. So let's do that on the drawings. So I'm looking at I'm starting with you don't have to say this before I can place it. So you can say this in my Sundays. All my real symbols here, reviewing to assembly. One. My movement here. I'm going to do a quick save on it's kind of I'm strong on 5-1. I don't feel it. So probably losses a minute hold it. Okay. Let's place this. So I'm just going to put the drawing over that. Assembly. All right. Okay. Put my place this one. Place here. And then this orientation. I thought I looked at this. I look at this. That should be able to say base view. It's the end of the part. That's it. Oh, it's not. Sorry, I never finished my welding. It won't even allow me to place it. It knows I'm in like an edit mode. All right, yes, if this ever happens to me, it's good. I love it. There it is. Now I'm just kind of left that. So it would be like it would be the same thing in a sketch. It won't let me do that in a sketch in a part or in a sketch in an assembly. Little like house problems. Yeah, I think. Got my two welds. Let's go. Let's go. Those things should so I'll just rotate this around. Well, I didn't really pay any particular attention on how I do want this to be aligned this way. That looks better. And I'll add my view label to this. It's probably gonna be a little too big for this. I don't know what it's going to one to one maybe. I don't know what I'm gonna do. It's the scale is showing. The 3/4 scale. Let's jump into the weld symbol. It's really mostly all putting that once. You could really apply it to both sides. You just need to pay attention uh, which one is going to be the other side, which may be the other side. That's the thing. But technically, I could point to either side because it's easier for me as a drafter to put where I could put that. You know, these weld symbols take up a fair amount of space. So whatever side you need to, I think I'll just stick with that. It's it. Just better. So I just need to determine what's all there. So I'm not going to use the last view. You shouldn't say no, please. So, and oh, this is kind of nice. Maybe if you build it wrong, it's just a quick swap. That's kind of and maybe I'll play it that way. For mine, the arrow side view, if you go it right, so the way this kind of, said, it's, just throw it on the arrow side. So I don't have to change the symbol there. You just need to know the size. So what, leg one, leg two. I just think it's not super clearly communicated well. Which one's leg two, which one's leg one. You could slap a dimension on, I don't know, there could be not a weldment, it's just that the two parts sit together. We won't know which way it's. But it's 3/8, so I'll put 3/8 in the first one. So it's about half. But unequal length. Hopefully fix that for you. Non-intermittent welds. So that's really it for the arrow side. Move this over so it's about. And then this side is just the single bevel, right? So it looks like the filler weld, but it's upside down. So bevel glue, just the bevel. Perfect. And then it opens up, a little more complicated than a filler, just because it just has more potential parameters to set. And so if I just work this kind of, I like to work like I think of the outliers as it's kind of the more rare things to add, and the stuff right next to the weld symbol is kind of where the most critical stuff, the most normal stuff goes. So maybe think of that like this is the prefix. That's a little bit of an outlier. Definitely more common to have the leg lengths on the fillet weld. Here we have the size, and we have the depth, and we have a prefix. Up here we have a gap, which can also be root opening. I'm surprised that doesn't say root opening. And then we have angle, and then we have like a finish, secondary fillet weld. So it can get kind of complicated. And we do a few complicated. Then we have length over here, just like a fillet weld, and maybe pitch. Even for a groove weld that I wasn't filling up completely. Ours is filled completely just like it was on the fillet weld side. So I don't have an intermittent weld going. Even in a groove situation, I don't have an intermittent weld. And then we have, these are kind of finish symbols, right? Then we have a brazing. I have some. Remember this. Let's see here. Size. So this is what I think what's confusing here is I have a parenthesis size or I have one that's not in. So if I put in 3/8 here, and jump over to the next box. That one doesn't have parentheses around it. So let me just check. I put in 3/8 here. Yeah, it just shows you it's going to apply parentheses around it. So let's talk about what the difference is between the willingness, what is it? Okay, so in my mind, like I should study before I just have them willingness. But this should be the size. I feel like this is maybe like theoretical depth. That I'm doing it's 3/8 plate. I've done the joint prep to 40 degree miter bevel on that plate, all the way through its 3/8 thickness, and so the size of that well was 3/8, which I think is the depth. They consider that kind of the depth. This one here, which is called size, is maybe the actual size, because it goes into what I was just talking about. When the welder applies the weld, they will get the through thickness filled likely because that's how they're trained, is not to leave concave welds and to fill through thicknesses. Like that's just all part of their training. And so in this one, we can, especially in a bevel welding symbol, it's just going to be maybe the actual size. Think of it as actual size. The welder's going to put in 3/8 weld, but we are allowed to be 1/8 of an inch over flush on that one surface. So it could be up to a 1/2 inch weld. The size of the weld measured kind of through the throat or the thickness of the weld. Even though it's doing a 3/8 job of plate welding, the actual size, we could designate that and control that as well. So this, I would feel like this, I would probably use one or the other in this case. I would say by its actual size or kind of its theoretical size. And I'll correct myself if I know I feel like this one confuses students which one, but this seems like the size. It seems like where I should go. Just because it's in parentheses, or maybe approach it like it's a reference. I think that makes sense. It's kind of like a reference dimension in a way. It's in parentheses. The one that's not in parentheses is more you're driving, a more common place to put the size of it. You know, they call it that. Okay. And then I call out the degrees, right? So we just called out, and that's critical to know. There's always a threshold. The degrees that are with the joint preparation is highly controlled. Like most weld procedures will have the allow included angle, and it might be a range, but it might be a range that it's like 30 to 35 degrees. It might be a range of a plus or minus 2.5 degrees on each side of this or something. Like it's going to be a pretty tightly controlled That really affects the sequence of welds. It affects how much weld deposit. So it's controlled on what the beveling is going to be for the groove or for bevel groove type weld. So is there anything else on this? I think this one I can see. I don't remember if they just like yeah, just that. That's how I would call out the weld that's being done. And I'll look in if it's hang on to the end of the video. Essentially, this is done until they just go ahead and view the view of the dimensional parts listed, but I was going to show where yeah, in the book on 622, yeah, it looks a little different than how it does an inventory, but they have the parenthesis one. They even show the parenthesis like size on the yeah 622. I'm just looking at the weld symbol nomenclature and how they have everything called out. And on the other side, on the top of the line, they do show size and then they're talking effective. And that's what I'm saying is that the actual size of the well kind of has this effect of fidelity. And sometimes that's the more critical way to cut away. Um, or I may control my well size versus the other one, which in our book itself is the depth of preparation, size or strength of certain wells. And it's that's definitely the most common place to kind of put the size. And the size of the well is the depth. So it makes sense in a way that we call size. But because V groove or really the size of the weld is kind of yeah, the weld is an active fill. And theoretically, I should put 3/8 to call the through thickness of the material welded sufficiently. So say okay, and then I'll apply the next one. And oh, I wanted to just test this since I kind of forgotten. But what if I do want to change this going over to this weld? And then I'll flip this over. Because it just turned out in my drawing, oh, this looks better to have it over on this side. Well, now technically this is not correct, right? This is arrow side, this is other side. This is now a power to contradiction of my weld symbol and I'm showing the grain. And so can I just simply go in here with the flip? Oh, yes, I can. So that from a drafting perspective, that's super handy that I can say. Now, arrow side is a double groove this yeah, double groove well, and the other side went really well. So it's kind of cool. I think I will put over here does nest. But I feel like as a drafter and inventor, you have a little more liberty of being like not getting your weld symbols as long as you remember which way is which. You see, say the closing.